like to start the presentation with a question to you. Would you swim in a historically contaminated urban river if there was a period when the river water did not exceed primary water quality standards for primary contact recreation, and in this example, swimming? A similar question was posed in the Anacostia River Use Survey, and that question noted, in the future, when the Anacostia River meets water quality standards for swimming and improvements have been made for safe river swimming, how often would you swim? And out of about 1,100 responses, greater than 80% of the people said they would swim at least once a month. So why is there public interest in swimming now? Well, there's public interest because there's a lot of change afoot and a lot of improvements within the system. Just a few examples. DC Water's Clean Rivers project, so the long-term control plan, is well on its way. This is a $2.67 billion project, and the Anacostia tunnel system is already operating and has been operating since March of 2018. Between March 2018 and December 2019, about 7 billion gallons of combined sewer overflow have been removed from entering the water body. So that is a demonstrated positive impact to the receiving water body. In addition, DOEE's Anacostia River Sediment project has come out in 2019 with an interim record of decision, and in that it identifies 11 early action areas up and down the river that will be cleaned up in terms of removing PCB contamination. Then lastly, another example is the Anacostia Watershed Society. Over the last several years, Anacostia Watershed Society has issued report cards indicating water quality, and in some of the recent years indicating water quality improvements within the Anacostia. So what would swimming look like? A study was done in 2018 with a grant by DOE to the Smith Group, and it was entitled the Anacostia River Pool. It was a feasibility study for a swimming facility on the Anacostia. And it asked a suite of questions, and some of those questions included, is this possible? Has this been done before? And so it highlighted US examples of where swimming was done in urban waterways. It also highlighted several examples in European urban waterways, Copenhagen, Paris, London, for example. And what could swimming look like? And it was envisioned that swimming could look like various different forms within the Anacostia River. It also identified locations where, or identified candidate sites where swimming might be possible. Transitioning to water quality standards, within the district, we have 5 designated uses within within the system. The first is primary contact recreation. Second is secondary contact recreation. We have aquatic life designated use, human health, and then finally navigation. For this presentation, focusing on the primary contact recreation and specifically E. coli as a criteria associated with that designated use. So what is that criteria? It is 126 mpm per 100 mil, and so that would be 5 samples over a 30-day period. And we also have the single sample value, which is 410 mpm per 100 mil. Give you some insight as to historical and recent water quality. The plot in front of you is the annual average E. coli values in the Anacostia River. So this is a data set from about 8 to 10 sampling stations up and down the river. And the data set is a period of record that goes all the way back to 2008 through March of 2020. On the first y-axis is E. coli MPN values, and on the secondary y-axis is precipitation represented in the orange line. Looking at that graph in a little more detail, a couple of take-home points. Want to indicate the substantial annual variability. So looking at 2012, when E. coli values averaged about 250 mpn, all the way up to values during various different years, somewhere in the range of 550 to 600 mpn. On the graph 2, I've also shown the single sample value as context, so the 410 value, and also the geomean at 126 mpn. And generally speaking, you see this loose association between precipitation in inches and the E. coli values from year to year. Looking at that data set from a slightly different perspective, so the period of record is 2008 to 2020, and it's looking at all the Januaries during that 12-year period, all the Februaries, and all the way up to the Decembers. And you can see that again, lots of substantial monthly variability. For context, showing that SSV and that geomean. And within a monthly context, you're seeing these windows of, well, I'll call them windows of opportunity related to the 410 value that you see. On average, values are below that criterion during March and April, so during the early spring periods, and also during the later summer, early fall periods of September and October. A recent time series of E. coli in the Anacostia, so this is using data from the same sites, and stepping back from March 2020 all the way back to January of 2016. E. coli on your first y-axis, precipitation shown on the secondary y-axis, shown in orange, SSV and geomean for context. Lots and lots of variability from month to month. But I hope you can see the several months below the 410 value, and some months are in fact below the 126 mpn per 100 mil geomean value. Again, indicating that there may be opportunities to consider or think about swimming in the future. I have tagged the starting point of the DC Waters Anacostia tunnels in March of 2018. I previously mentioned that between March 2018 and winter of 2019, it removed about 7 billion gallons of combined sewer overflow into the system. So given the past, our changing conditions on the ground and recent data, are there opportunities for swimming? And it seems that the popular perception is that indeed there is opportunity. There's extreme stakeholder interest to make that opportunity into reality. As an agency, we're bought into that. We are ourselves interested in creating opportunities or increased opportunities for recreating in and on the river. So what are we doing to help with this? We're looking both outward and inward. We're looking at examples around the nation. So looking at things that are going on in the Charles River, looking at things that are going on in the Willamette River in Oregon. We're also talking to our state neighbors. So looking at Maryland and how they issue swim advisories within a freshwater system perspective. And then inwardly within our agency, proposing to adopt the 2012 recreational criteria. We did that in 2017 and we'll do that in the near future. And then also thinking about other opportunities to improve the process to approve swimming events. So our next steps for water quality standards. As mentioned, we'll propose the water quality criteria, the 2012 recreational criteria. We did that in 2017. We have a flavor of how that may play out, at least initially. We anticipate substantial stakeholder comment, both from environmental stakeholders and the permitted community. We also anticipate the permittee may request a use attainability analysis. And then additional decision points and tools to improve the approval process for swimming, thinking about that 2012 recreational criteria and opportunities to consider the statistical threshold value as a do not exceed value in swimming, exploring and understanding more how beach action values could be used for local decision making on swim advisories within a freshwater urban context. And we're also interested in new tools and data-driven approaches to make decisions on swimming. So interested in the quantitative PCR method, 1611 method for enterococci as real-time decision-making tool. So that 2 to 6 turnaround time to make a decision is really interesting to us. We also have a new project with USGS that will create a bacteria forecasting model. So I'd like to thank you for your time, and if you saw anything that resonated with you, please reach out to us. We'd love to hear from you. Thank you.